Hi, so today we're going to talk about measures of variability or measures of spread. So today's objectives, we're going to distinguish among different sources of variability and then develop concept of standard deviation as a measure of spread. So first let's talk about what variability is and what we mean by that word. So an average, which is what we talked about in class today, is an attempt to summarize a set of data using just one number. So the center or the average, or sometimes we use the word typical to talk about that summarization of the data. So the typical grade for students in this class is maybe the mean or the median or the mode. But an average by itself may not always be very meaningful. That might tell us what's typical or what's in the center, but we also need a statistical measure that tells us how spread out the data is, because that tells us how consistent are these numbers. Are they really close together, meaning that everyone was doing about the same in this class? Or are they really spread out, meaning that some people are doing way better than others? That can tell us a lot about that set of data. So one measure of spread is something we've already talked about, which is the range. So the range is the difference between the largest and smallest values of a data distribution. All right, so the biggest number minus the smallest number. So for example, a large bakery regularly orders cartons of Maine blueberries. The average weight of the cartons is supposed to be 22 ounces. Random samples of cartons from two suppliers were weighed, and the weights in ounces of the cartons were from supplier 1 were 17, 22, 22, 22, and 27. And then the weights in ounces of the cartons from supplier 2 were 17, 19, 20, 27, and 27. We're going to find the range for each supplier. So for supplier 1, the range would be the highest number, which is 27, minus the lowest number, which is 17, and that comes out to 10 ounces. For supplier 2, the range would be the highest number, still 27 for this data, minus 17 is the lowest number, which gives me 10 ounces. So they both have a range of 10 ounces. So one of our goals when deciding on a measure of variability or spread is to determine how consistent the data is. I used that word earlier. So while the range can help us with that, it's not always the best statistic to use. For that last example with the blueberries, the ranges came out exactly the same. But are both sets of blueberry carton weights equally consistent? If I go back and look at them, I might see that supplier 1 has more cartons that are that desired mean weight, which is 22, whereas supplier 2 doesn't have any cartons that are that desired mean weight. So they're not really equally consistent, and a range is not really showing us that. It's just showing us literally the biggest minus the smallest. So there's other measures of spread that we can use that are helpful in this regard. So one of them is called the standard deviation, which we're going to talk about in this lesson. And the other one is called the interquartile range, which is something we'll talk about in the next lesson that we do next week. So we're going to go ahead and calculate a standard deviation. The calculation for standard deviation is kind of complicated, but don't worry, there's good news. I'll show you how to do it with the formula and how we actually calculate standard deviation. I won't ever make you memorize the formula, but I want you to see kind of how it's calculated, and then I'll show you some quicker ways we have of getting to the standard deviation without having to calculate it ourselves. So we're going to start with the set of data, -4, -2, 3, 4, and 6. We have 5 numbers in this set of data. Some of them are negative. Negative numbers happen in real life, guys. Let's just deal with it. So the first step is to find the mean, or what you might call the average. So the mean is just the one where you add up all the numbers and then you divide by the total numbers there are. So I'm going to add together -4 plus -2 plus 3 plus 4 plus 6, and then divide by 5 because there's 5 numbers in my list. So remember, you can just use basic calculator on your phone if you have one. You can also go to Google. I'm just going to use the Google one. So -4 plus -2 plus 3 plus 4 plus 6 gives me a total of 7. And then I'm going to divide that by 5 because there were 5 numbers in my list. And I get a mean of 1.4. Right? So I'm finding the average. Then my next step for standard deviation is to find what we call the deviation. Deviation means how far is each point from the mean. So how far is each value in my list from that mean of 1.4? So finding that distance is basically just subtracting. So I'm going to take each value and subtract the mean, which is what we have here. So we have x minus x bar. X bar is the symbol that statisticians use for mean or average, and then X would just be the number. So we're going to take each number and subtract the mean and see what we get. So for -4, I would do -4 minus our mean, which is 1.4, and I get a deviation of -5.4. -2 would be -2 minus 1.4, which gives me a deviation of -3.4. Again, you can use your regular basic calculator on your phone for this or in Google. Nothing too fancy. You don't have to try to do this math in your head if you don't want to. Calculator's fine. All right, so for 3, we would do 3 minus 1.4, which is 1.6. Then we do 4 minus 1.4, which is 2.6. And then we do 6 minus 1.4, which is 4.6. So we have our deviations. So this question I asked in your notes says, what happens when you add up the deviations? Because that's our goal. We want to know the standard deviation, which kind of means typically or on average, what's the deviation? How far are these points from the mean? But if I add up all these numbers, I get 0. The deviation is 0 when I add them all together. And that's not very helpful. So if I was going to find the average or standard deviation, adding up those numbers is not helpful because they add up to 0. So what do we do instead, right? What can we do to keep that from happening, from them adding up to 0? Well, one option would be to take the absolute value of the deviations and just do positive numbers. But we're not going to do that because statistics and statisticians like to do things a more complicated way. There are reasons for this, but it's not something I'm going to get into in this lesson. But what they do instead of just making the numbers positive is they square them. So we're going to square the deviations. Remember, square means multiply by itself. We're going to multiply each deviation times itself to get the squared deviation. So the squared deviation is just that x minus x bar, the number minus the mean, and then we take that deviation and we square it or multiply it by itself. So for the -4, our deviation was -5.4. So I would do -5.4 squared, or -5.4 times -5.4. Remember, when you multiply a negative times a negative, you get a positive, so that's why this is going to work. And that gets me 29.16. Again, I can just do that in my calculator. It gives me 29.16. So I can just do that in my calculator, no big deal. I'm going to go through all my numbers and do that. And now when I add up all the squared deviations, I get a number that's not 0. And that total in that second column, that total of the square deviations is called the sum of the square deviations, which is a good name for it, right? We're adding up all the squared deviations. So now we're getting somewhere. Again, our goal is to find what is the typical or average deviation from the mean. So I squared them to make them positive. I've added them all up. Before we get to the next step, I wanted to kind of add in a little just thinking practice. So what if we added 2 more points to our set of data? 1 point that was 2 units below the mean, and another point that was 2 units above the mean. The question is, would the sum of the square deviations, the 71.20 number, would it increase or decrease or stay the same if I did these 2 extra points? Okay, so thinking about that, right, if I add a point that's 2 units below the mean, well, its deviation would be -2. If it's 2 points below the mean, when I do that number minus the mean, I'm going to get -2. And so that square deviation would be -2 squared, which is +4. For a point 2 points above the mean, its deviation will be 2. If it's 2 points above the mean, when I do that number minus the mean, I'm going to get 2. And then 2 squared, my square deviation would be 4. So that's going to add a total of 4 plus 4, or 8, to that sum of the square deviation. So something to note is if you were adding points to your list of data, it almost always is going to increase the sum of the square deviation. The only time it wouldn't is if you're adding a number that's exactly the mean. So if I add a number to the set of data, a 6th number down here that was exactly 1.4, then it's 0 points away from the mean, so it wouldn't add anything to our square deviation. Otherwise, it's going to increase. So let's go back to actually calculating our standard deviation. Right? So now that we have the sum of the squared deviations, remember again, our goal is to find the average or typical standard deviation from the mean. The next step would be to divide by our sample size, right? But for sample data, we actually divide by 1 less than our sample size, or n-1. Now there's a reason for that as well. Typically, statisticians say when we're dealing with sample data, we want to leave a little margin of error. So we just divide by a little bit of a smaller number to give us a little wiggle room in my final answer. It's not something that you ever need to be incredibly worried about. Why do we divide by n-1 instead of n? That's just something that statisticians decided to do, and so we just follow their example. That's just the general formula for standard deviation. So doing that, dividing by that n-1 will give us the formula for something we call variance, which the symbol we use for that is s squared, which we'll talk about in a minute. So this is my official formula over here on the right for s squared, which is variance. We did that x minus x bar, the number minus the mean. We squared that number. And then if you remember, our next step was we added up all those numbers together for all the numbers in my data. So that little E looking symbol means sum of. It's a Greek letter, it means sum of. By the way, if you're taking notes on your computer and you're wondering, how do I get these symbols into text format? If you go into the menu bar and you click insert, and then there's an option for special characters, and then you can kind of like draw the symbol you're looking for and it'll pull up a list. So that's one way. Otherwise, you can just kind of put an uppercase E and hopefully you'll remember what that means. But we added up all together, all of those squared deviations, and then our next step is going to be to divide by n-1. So remember that total came from the bottom of that second column. So when I actually find my s squared, my variance, I'm going to take that total that I already found in my little table, and I'm going to divide by n-1. So we had 5 numbers in our data set. 5 minus 1 is 4. So we're dividing 71.20 by 4. Again, if I just do that in my calculator, I get that answer of 17.8. So that is where that came from. So last step, promise we're almost done with standard deviation. The units for variance are squared. Remember, we squared the distances or the deviations back a couple steps ago. So to get back to our units, to actually do the standard deviation, we now have to kind of undo that. So we squared things earlier, now we have to unsquare them, otherwise known as a square root, to get s, which is our standard deviation. So once you find the variance, which is s squared, we're now going to find the standard deviation, which is just s. In other words, we're going to take the square root of that variance to get our final answer for standard deviation. So s equals the square root of that 17.8. Again, I can do that in my calculator. There's my 17.8. I'm going to hit my square root button, 17.8. And I get 4.219, or if we round it, it'll be 4.22. So that is how I calculate standard deviation. Is it easy and quick? Absolutely not. Do you need to memorize the formulas and the steps? Probably not. And I'm going to show you in a couple of minutes how we can use a quicker way to calculate standard deviation. But you should be familiar with the steps. You will kind of see questions on assignments about the steps. One final note here, and we'll do another practice. If you have the entire population, so these are examples where we had just a sample of data. Remember, a sample is we only took data from some of our population, from a select group. If you had data from the entire population, we would actually just divide by n. So instead of dividing by n-1 like we did for the sample, we would divide by n instead of n-1. And the symbol we use for population standard deviation, instead of s, we use the symbol, it's called sigma. This is lowercase sigma. And then the symbol we use for population mean is another Greek letter that is mu. All right, so we're going to practice that if we had measurements of the level of phosphate in the blood of a patient in milligrams per deciliter of blood made on 6 consecutive visits. So we have 6 different numbers down here. These are the numbers in our X column. Those are the phosphate levels for this person. So our first step would be to calculate the mean. So I add up all 6 numbers and then divide by 6. So I add it together, 5.6 plus 5.2, etc. And then I divide it by 6. Adding those up got me 32.4. 32.4 divided by 6 is 5.4. The next step is to find the deviations and then the square deviations for each number. Remember, that just means you're subtracting the number minus the mean. So we did 5.6 minus our mean is 5.4. And that got me a deviation of 0.2. And then I squared it. 0.2 times 0.2 is 0.04. And then I did that for each number in my list of data. Remember, even if the deviation comes out negative, when I square it, it becomes positive. And that's the point of why we square it. So I did that for each set of data. And then I added them all together. And this down here, that 2.06, is my squared deviation, my sum of the squared deviations. So remember, the next step is to find the variance, where I take the sum of the squared deviations and divide by n minus 1. So 2.06 divided by n is just the total sample size, so 6 minus 1 is 5. 2.06 divided by 5 comes out to 0.412. So that's our variance. And then our final step to find standard deviation is we take the square root. Remember, we squared the deviations. Now we have to undo it. So square root of 0.412 is 0.642. So our standard deviation on this one is 0.642. So now comes the point where I tell you the quicker way to do things. In real life, we don't calculate standard deviation by hand of every set of data. That would take forever, and it's ridiculous. So your TI calculators, TI 83s and TI 84s and above, do have a way of easily and quickly calculating standard deviation. But I know that some of you don't have access to TI calculators right now, so I'm going to show you an option to use on the internet. So the first step is you're going to Google search standard deviation calculator and click on the first option. So if I go to a new tab and I search standard deviation calculator and then push enter, I'm going to have you guys click on this first one. It should be calculator.net. If it's not the first option, maybe scroll down and find the calculator.net option. Okay, so now I have this little box where I'm going to put my data. So my data is, let's just go back and use our set of data from here. All right, so I've got all of my data typed in. Again, I just put a comma and a space between each number. I'm going to click and say this is a sample, because remember, with populations, we divide by n. With samples, we divide by n minus 1. We're always going to use the sample formula unless I tell you otherwise. So always do sample. So I'm going to hit calculate, and then what comes up is the result. It tells you what the standard deviation is right here, but it also is going to show you the steps. It also tells us the variance, and then it shows us the steps for how we got the standard deviation. So again, you're using standard deviation calculator, using the first option, put your data in the text box provided, putting a comma between each option, click on sample, and then click calculate. Then it'll give you that result. It'll tell you what your mean is as well. It tells you your variance in a couple different places, and then it tells you your standard deviation. So I'm going to go back to that very first example and just kind of bring that back into things. So if you remember, we had the blueberries. Supplier 1 carton weights were 17, 22, 22, 22, and 27, whereas for supplier 2, it was 17, 19, 20, 27, and 27. So we found the ranges of them before, and they had the same range. Sometimes we have numbers that are more or less consistent, and we can't necessarily see that with range. So if I were to calculate the standard deviation for supplier 1, if I use that Google calculator like I just showed you, for supplier 1, the standard deviation is 3.54. For supplier 2, my standard deviation is 4.69. It's a little bit bigger, which tells me that for supplier 2, those weights are a little bit more spread out, or a little bit less consistent because they're more spread out than supplier 1. So even though the ranges are the same, the standard deviation tells me a little bit more about how spread out those values are from the mean, which is good information to have. And that is it for today's lesson. And so we will recap on standard deviation next time.